Yeah. Okay, Stefan, can we start now?
Yes.
Yeah. Okay. Yeah, I will introduce you for some minutes, and we have also welcome speech from the head of the department. It's not too long, and this is hard also. Okay, we will open this meeting today, and yeah, good afternoon, the participants, ladies and gentlemen from Semarang and also some of the city in Indonesia, and also good morning for Stefan, Professor Hans Stefan Schillers from Würzburg University in Germany. Nice to meet you. And yeah, in 2018 we meet each other in Würzburg, and we hope that you will visit Semarang. That perhaps this is a start point for our collaborations to conduct the joint course and also joint research and other. And before we start our meetings for 1 hour and one half hour for the discussions, I would like to introduce you to the participant. I got this slide. Yeah, okay. Ladies and gentlemen, this is Professor Hans Stefan Schiller, and he is the Dean of the Faculty of Mathematics and Informatics, and he's a lecturer of the mathematics educations, and his specialty in the mathematical modeling. And there is some of the curriculum vitae, and I think the participant would like to access the curriculum vitae directly on the internet, on the website of the Würzburg Julius Maximilians Universität Würzburg. Yeah, because this is a very nice university already there, and I have the relationship with the university because Matthias Ludwig, my supervisor, is the PhD from the Würzburg University also. Okay, and these publications and also some of the projects, and we have also the plan for the projects between Indonesia and between UNNES and Würzburg University. And hopefully we will conduct some of the projects together. And okay, and now the Professor Schiller would like to present about the M in STEM, and theoretical insights and practical issues for future-oriented research educations. And of course, this is not only about the mathematics, because this is a STEM, science, technology, engineering, and mathematics. So if we look at the data of the participant, there is also the participant not only from mathematics, but also from chemistry and also other science fields. So this is various, not only from mathematics, but also from other and we can also see that the participants from UNNES and also from other university. We have the participant from Aceh, this is Unisa Aceh, Mr. Mayelizar. Thank you for coming. And also from Austria, this is Johannes Kepler University, Linz, Austria. There's also joined Mr. Imam, is from Indonesia, but doctoral from in Austria, with that is Professor George Lafixa. I think you know well, but Professor George Lafixa, and also this also participant from Southeast Asia Quality in Math, Siang Kitab in Math from Yogyakarta also joined. And okay, and among with us is also Professor Mr. Dr. Mulyono. This is the head of the Department of Mathematics. That Dr. Mulyono and also Professor Schiller, you also already signed the memorandum of agreement to conduct some of the projects. So with his agreement, so I can conduct some of the project with you. So please, Mr. Mulyono, Pak Mulyono, monggo mungkin bisa memberikan sepatah dua kata. Silakan Pak Mul.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Puji syukur alhamdulillah kita panjatkan kehadirat Allah pada sore hari ini kita dalam keadaan sehat walafiat untuk mengikuti kuliah umum dari Profesor Hans dari Jerman. Kegiatan ini merupakan rangkaian kegiatan perabuan daring yang sudah ini ke-9 ya, ke-9 dilaksanakan oleh jurusan Matematika MIPA UNNES. Pada kesempatan hari ini, saya atas nama jurusan Matematika MIPA UNNES mengucapkan terima kasih kepada Bapak, Ibu, Saudara, peserta kuliah umum pada sore hari ini. Mudah-mudahan nanti kita bisa mengikuti kuliah umum ini sampai selesai dan bisa mengambil ilmu yang akan disampaikan oleh Profesor Hans. The Honorable Professor Dr. Han, thank you for your time and willingness for this activity. Sekali lagi Bapak Ibu peserta kuliah sore hari ini, kuliah umum, selamat mengikuti kuliah umum ini. Mudah-mudahan bisa mengikuti sampai tuntas dan bisa mengambil hikmah atau memanfaatkan ilmu yang disampaikan oleh Han. Apabila dalam kegiatan sore ini ada kekurangannya, saya atas nama jurusan Matematika UNNES mohon maaf. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Mulyono. Thank you, Dr. Mulyono, for the welcoming speech, and Professor Schiller, that Dr. Mulyono said thank you for you, and also for the participant for joining this course, and hopefully this gives a beneficial for us, and the collaborations will continue in the future. And please know this is time for you to present, and we will hear that at the moment there is 134 participants and still waiting for others participants. I think okay. And before that, Bapak Ibu silahkan kalau ada pertanyaan bisa diketik di tulis chat, kalau mungkin akan menyampaikan dalam bahasa Indonesia dipersilahkan, nanti tim akan memberikan mentranslate gitu. Jadi tapi kalau ada yang nulis bahasa Inggris atau menyampaikan secara langsung disilahkan. Okay, please Stefan, this time is yours.
All right. So thank you, Professor Mulyono, and thank you, Adi, for your warm welcome words. I'm honored to give a talk here, and I will try to give you an insight in my perspective about the mathematics, that's the M, in STEM, so in science, technology, engineering, and mathematics education.
Can you switch the screens, because this okay,
it's the wrong one. All right.
Okay, perhaps you can
just a second.
Okay.
So this is the right one?
It's correct, yeah.
All right, so thank you for this hint. Well, I'm honored to be a guest talk here at Samarang University. I'm working a lot in this topic STEM now, because mathematical modeling is a very important part in STEM, in my opinion. And there is a big orientation in STEM, where one can see that the motivation for looking into mathematics in STEM is very important. And this is a citation from the former US President Obama Barack, who has told that STEM is more than a school subject or the periodic table or the properties of waves. It is an approach to the world, a critical way to understand and explore and engage with the world, and then have the capacity to change that world and to share this accumulated knowledge. So you can see that if you take mathematical modeling into account, combined with this perspective of Obama from 2015, one could say, well, mathematics is that important because it's the ground for all those subjects we have to teach in technology, in science, in engineering, even in computer science. So that one has to be aware that mathematics is fundamental for all these things. And this is my motivation to give you this perspective about the M in STEM. And for this reason, the outline of my talk is divided into two parts, mainly a theoretical part, which consists of the introduction about STEM education and STEM in classrooms. So this is I think very important. Then the M in STEM. So I want to talk about mathematics itself in the context of STEM. And then I want to give you a theoretical perspective on mathematics as a crucial discipline to promote critical thinking, because critical thinking is one of the most important things one has to be aware if he attends school. And if he leaves school, he should be able to transfer this critical thinking into real life situations. So for this reason, this is a theoretical perspective, but in this point 3, the practical issue begins to work. As you have seen, one has to be aware that he has to create critical thinking in school and transfer it to real life situations. So the second part of my talk is about practical issues. And I will give you some examples for STEM education as I see it and as my working group is working on it. And at the end, I want to summarize and give you a short outlook. So this is the program for the next 60 minutes or something like the 60 minutes. And then we have time to have a short discussion. Don't hesitate to talk. I will try to answer your questions as good as possible. So let's have look at the STEM education in STEM classrooms. What are we talking about? Well, if we're talking about STEM, we have to clarify what we think or what we mean with STEM. STEM is the acronym for science, technology, engineering, and mathematics. It was first mentioned by Judy Dramalai, and it was an attempt to emphasize the importance of all those subjects summarized by this acronym STEM. So a first attempt to emphasize the importance of subjects. This was the very first beginning when one was talking about STEM. Because of the importance of this approach, STEM has become an initiative that indicates the integrative and or the collaborative STEM education as a viable endeavor. And STEM as an initiative should provide all students with critical thinking skills that would make them creative problem solvers and ultimately more marketable in the workforce. So you see, there is a strong connection with the workforce and with political reasons that STEM has become an initiative. Well, I don't want to focus on the political side. Although the political side is important, I want to focus on STEM education with different views. Because if you think about STEM in education, you could think about different approaches, as Linda Hobbs has done it. Linda Hobbs, you see the picture up here, has said that there are at least 5 approaches to STEM. You can teach STEM with each discipline independently. That means you teach science, you teach technology, you teach engineering, and you teach mathematics. This is, I would say, in Germany, and I'm an Austrian, so greetings to my homeland in Linz. I'm from Salzburg. This is as it is in Germany and in Austria. Each teacher is teaching each discipline independently. But one could ask, is this a very good approach? So Hobbes has mentioned that there are 4 other approaches one could think about. The next approach she's mentioning is the STEM. So all 4 disciplines are taken into account to emphasize of only 1 or possible 2 disciplines. So this could be science and mathematics. They are not focusing on technology and engineering, but you could also say, well, we're focusing on technology and engineering and not on science and mathematics. So one could ask again, is this a good approach? So Hobbes has mentioned another approach. That's the integrated approach, which in my opinion is the most interesting approach. You're focusing on one subject and you integrate the other subject in the one you're focusing on. And there is another possibility that the STEM curriculum is divided into the respective disciplines with an integrated approach. So this would be a very formal approach where the curriculum is very important. And the most interesting approach, in my opinion, is the integration of all subjects by one teacher. But this is a very hard one because there you have to know a lot about math, about engineering, about technology, and about science. So in my opinion, the approach, the integrated approach here, where you're focusing on one subject and you integrate the other 3, is the one which is the approach which I like most, but everyone has to decide what he wants to do. So there is evidence-based data for all these approaches, and all these approaches can be found all over the world. Focusing on the curriculum, you should be aware that STEM empowers to think and act in a reflective and comprehension-orientated way. So this is very important. And it opens the opportunity to master challenges in the future labor market. For this reason, I have looked what is done in Germany for the future labor market. And if you look through the science pages in Germany, especially from the ministry, you can be aware that we had a science year in 2018 where concerning the future labor market, necessities, potentials of our world today and tomorrow was shown, and they have integrated it into a picture which I'm allowed to use. You see here 3 people and 3 pictures. And I think this picture at the whole is very, very interesting because you see that we have people working and robots who support the people. You see a lady with a tablet, and behind you see an avatar. So the augmented reality is a very important one, and the bionic behind it is very interesting in terms of mathematics and mathematics education. And then you see a 3rd picture where a young man is wearing lenses. So this is a virtual reality lens where he is navigating through a virtual room. And in Germany, we have this year a very big initiative about artificial intelligence and hiring professors for artificial intelligence. So I think in the future, artificial intelligence will head to school, and future teachers, prospective teachers, have to be aware that they have to teach math as well with a virtual lens. But this is just for the future. But concerning this picture, we will come back to it once more, because I think we have a very good approach to think about all those things which was mentioned in 2018 already, to work with students and with students in school. So focusing on STEM education in classroom situations, we have to be aware that STEM has to be considered interdisciplinary so that critical thinking can be developed. We also should focus on real life situations for integrating STEM disciplines to form abilities, dispositions as a set of skills and competencies. What does that mean? So this is another citation from the network funding and education, as you can see. When we take this into account, we have to be aware that teachers have to focus on the training of judgment and evaluation. And teachers, therefore, has also to be aware that they have to communicate science and technology, and that they have to take up vivid and likeful educational contents. So you see, the future teacher has to be aware about a lot of things which are in the context of STEM very important. That's the general view. So what are we thinking when we are looking at the M about the mathematics in STEM? The role of STEM, the role of M in STEM is a very interesting one, because if you argue with Gojak, that's the former head of the NCTM, the president of the NCTM, she said, well, mathematics is just necessary as a language of science. So the perspective as the language of science is important. And this is the problem on the same side, because oftentimes mathematics is the last letter of STEM and the forgotten quarter of STEM. So Gojak is telling this as well. And she tells so many people think mathematics is teaching kids certain skills and off they go to do them. But mathematics can be just as innovative and support the other letters of STEM in ways we sometimes don't think about. So this is my crucial point here. Mathematics can be innovative and support all the other subjects in ways we are not thinking about. So we should be aware that mathematics has to be mentioned as the underpinning to the other disciplines of STEM, as it serves as the language of science, engineering, and technology. So the language part is one part, but the practical part is the other one. So how can we strengthen mathematics? Well, if we want to strengthen mathematics, we have to be aware that this can be done very easy. So Silk et al. Tells one way to do this is repeatedly foreground the desired content while temporarily pushing other concepts into the background. Fitz-Allen just argues that a shift in the focus from the incidental nature of mathematics in learning activities to focus on the instrumental nature of the mathematics may be one way of making the mathematics more explicit within STEM learning context and activities. How can we approach that? Well, everyone knows that. Everyone is searching and researching about that. It's just an approach about the learning process. So we have to change the learning process to an experimental path of knowledge. So by changing our learning process to an experimental path of knowledge, we can strengthen mathematics in the context of STEM. And then we can have a look at the role of STEM and look at obvious facts. If we argue with a politician or with a researcher of mathematics, one would say, well, the importance of M in STEM is obvious because it's necessary for the economy. So I have found a paper published by the House of Commons where they are delivering STEM skills for the economy, and where one is telling that STEM is important, but no one is telling what STEM is. So STEM problems are a product of a whiteboard solution. No one is aware of what we're talking about. This is also a problem because STEM is always seen as a whole, as a product. And there are hardly realized facts, especially when one focuses about mathematics. So we had a big discussion in 2019 about air pollution by cars. And there was a medicine man who said, well, the pollution of a car is not worse than a cigarette. But he made a big mistake because he failed with the factor of 10 in his calculation. So you can see that STEM as indication of responsible citizenship is very important because everyone is talking about that if the media is taking this news up. So everyone has to be able to make judgments. Everyone has to be able to assess the validity of reports in media, politics, and economy, and so on. And for this reason, everyone should be able to think about consequences when making decisions, even in the long-term run. So you can see there are very important facts. We are teaching our students at university and in schools, but yeah, the general view is not realized in depth. So we have to look at M in STEM once more. The role of M in STEM can be described as very important, and we have to be aware that the mathematical learning process has to change to an experimental path of knowledge, as I has told you before. Then we have seen that mathematics serves more than a language to other disciplines of STEM. And we can realize by the last slide I've shown that mathematics is crucial for socio-scientific and ethical aspects in STEM, being able to judge consequences for long-term decision-making. And these three important points face the citation of Ananyandhu, who says the current century will demand a very different set of skills and competencies from people in order for them to function effectively at work as citizens and in their leisure time. So we should think about skills and competencies one should be aware. And Young has identified 21st century STEM competencies, which I show you in a short slide here. There are a lot of competencies and skills which are listed here. And if you look at this, you can see that critical thinking is one very important competence. Then you can see that mathematics itself is a very important competence. Learning strategies are very important. Time management is very important. Judgment and decision-making is very important. And last but not least, complex problem solving is important as well. So a lot of things which are very close to mathematics education. So I don't talk about all these competencies right now. One could tell, I would say, about 3 hours of each of these competencies. I want to focus on mathematics as a crucial discipline to promote critical thinking. The requirements we have to be aware are obvious. I have taken a citation of a person working in industry who says, even in the big data area, there must be people who critically question and validate the mathematical tests. I think this is very important. We have to test our own. And I think this is a very interesting citation because it tells we can automate a lot, but the automation has to be tested as well. And this connects, in my opinion, with critical thinking. Because critical thinking, as I understand it, is the way UNNES is doing it. It is reasonable and reflective thinking focused on deciding what to believe or do. Each person is to be aware of that. So critical thinking can be identified by abilities and by dispositions. Dispositions mentioned by Young are not enough to teach students to perform thinking operations and tasks, should be disposed to carrying them out on their own, unasked. And the abilities are a lot. There you have to be aware that you have to do basic clarification, basis for decision, advanced clarification, inference, and supposition and integration. And all these abilities are described by Young. So now we could say, well, everything is obvious. But when I look at those abilities and about those dispositions, I'm not sure how we can implement that in the real life school praxis in mathematics classrooms. So I have thought a lot about that, and I have thought with my very critical friend, Vince Geiger, and discussed a lot with him. And he said, well, you're right. But I think there is an approach I have done with Marilyn Goose and Dole. And I just want to show you this approach. This approach is very, very easy to understand in my opinion. You have personal and social things on the one hand, you have the work and the labor market on the other hand, and you have the citizenship at the bottom. And education, as I understand it, is important because it has to face all those things. And if you think about a cloud, you can say, well, in the cloud, you are able to think about dispositions and tools. And we know we are in the mathematical classroom, so we have to be aware that we have to talk about mathematical knowledge. And when we want to create a critical orientation. So we have to take up several contexts where we are confident with, where we have to work flexible, where we have to take risks. And then we have to represent them, we have to digitalize them, and we can do problem solving, estimation, and other skills which are important. And if you take this approach from Goose, Geiger, and Dole, connected to the dispositions and ability of Young, one could say, well, in the German context, we have a basis which we are talking about. This was funded by Heinrich Winter, a very famous German educator who did a tremendous important work for the competencies in Germany. And he told we should be aware that appearances of the world around us, which should concern or approach us all from nature, society, and culture in a specific way, should be perceived and understood. Then one has to be aware that you should be knowing and understanding mathematical objects and facts represented in language, symbols, pictures, and formulas as mental creations, as a deductively ordered world of their own kind. And one has to do dealing with tasks to acquire problem-solving skills that go beyond mathematics, so-called heuristic skills. So how can we think about this in a practical way? I want to show you a first example. I've done a lot of work with one of my team members, my doctoral student, Stefan Günster, who will be shown a little bit further, where we have thought about the global footprint network, because in terms of Greta Thunberg, everyone is talking about pollution of the environment. And I think this is a very important topic. And we thought, how can we integrate that in mathematics education? And we found this global footprint network, which is a good way to calculate ecological footprints by land use. So this is just a model, and we wanted to understand what the model is doing. So we have read the guidebook to the national footprint accounts, which is a documentation of the calculations. And there is a very important example called carbon land, where an equation is created that it looks like this. So you see certain parameters which are described. So the EFP is the ecological footprint associated with the product or waste. P is the amount of product extracted or waste generated. YW is the world average yield for product extraction or waste absorption, and so on and so forth. And if you take this equation into account, you can calculate with certain parameters, which is done in this documentation as well. And what you can see here is the calculation we have done. No, the calculation we have done is up here. So, sorry, the calculation we have done is here in this table. So you can see 30,520,906 gigahectares of fuel combustion is generated. And what the global footprint network was calculating was this one. So we had a difference, and we just were thinking about the mistake. Did we make a mistake? Did the global footprint network make a mistake? And we were not sure. So we have just asked each other, where is the mistake? And then, as we were not able to find the mistake, we just corresponded with the general footprint network. And it was easy. They told us, well, there is a missing detail in our documentation. The guidebook did not fully detail the calculation in this case. Prior to this above calculation, we remove a percentage of all emissions that is absorbed by the oceans. And we said, wow, we did it right. And we understood the model, but we were not able to find this percentage which was missing in the calculation. And there we just realized what critical thinking in terms of mathematical context means. So I just want to give you more examples about this and want to come to the examples in STEM which we are looking through a mathematical lens. And therefore I come back to this picture which I have shown you. We've seen that in this picture, we can see robotics and automation. We can see that in this picture is big data and bionics. And we have seen that in this picture is virtual, augmented, and extended reality. So what we see here is we have three important future-orientated topics which have to be aware in school as well. Can we work on that in school? And we're doing a lot of work in this. So I just want to give you a short insight in certain projects I'm working on with my doctoral students. And the first is about the extended reality. The extended reality is about digital escape simulations. So I had a colleague at my former university who was thinking a lot about how can we evacuate people very easy, very smooth, and very time optimized. And I said, well, this is very interesting, but this is very hard to calculate. And was thinking about how can we take this topic into school. And I found a PhD student who wanted to do this, and he's working on digital escape simulations. So what is he doing? He's creating rooms. This is a room here at the Würzburg University where we are located. And what he is thinking about is a discrete modeling situation where he is thinking about how can we evacuate these rooms in a certain way. So he's creating escape simulations by digital support, and he's doing this in a real world context because this building is real here. He's doing this with students and in student related situations. And there are several approaches about this. The digital support he's using is he's constructing those models, he's comparing those models, and he's simulating each step. So if you do this, you have to be aware that you have to do this in a discrete way. So you have a discrete graph here with knots and points and lines. And this abstract model just describes what you're doing. You have to add routers, you have to add connections. The nodes in the graph are defined by a position. The connections who are added looks at parallelism and integrates delay. And then you can simulate this room by escaping, by filling this room with people and by controlling this simulation. So you see a very interesting work, which I just want to show you with 2 short films. One can be seen here right now. So you see here the source code of the program, which creates this digital output, and you see points running here. And this is the very first simulation we have done, where we have thought about how fast can we evacuate this building. And of course, we have done further work, and the further work can be seen here. So you have here one room, and the points here are the people in, and one has to evacuate this room as well. So what you see here is just how fast can we get out of this room. And you can see that within 16 seconds, all the people are removed from the room. This is just a short simulation, how one could work about that and how extended reality can be integrated into mathematics classrooms. Another interesting idea about the extended reality is done by my postdoctoral student, Jan Wörler, who is working on virtual and augmented reality. And if you have a look at this, you can see an excavator with QR codes. And one can have a look at this excavator and the triangles which can be found here and can work with that mathematically. So you can create an abstraction of the real model by taking this into account. So you see here the QR codes, and if you go further, you can see the triangles and the measured length in here. Or you can create certain models from another QR code, which can be seen here. So you have a cone here, the QR code says cone, and one can have a look at the cones and the layers which can be created by cutting the cone with the layer. And this is that successful that this was published in a school book. So the QR code was integrated in a school book, and one is taking his cell phone and looking into the school book. So this is what Jan Wörler is doing, and he's doing this with the software Fuvoria, whereas André Kreuvel, who has done the escape simulation, is programming on his own. So you can see, taking extended reality into account is a very big chance for mathematics education. And it is not that far away that we cannot implement it into our real life situation in school. The next point I want to mention is the big data. Well, the big data is a very important topic because if you work with big data, you just can't think about certain situations. I have taken an example which I created with a colleague. It's about refueling a car. And we have collected several prices of refueling stations. And the task, therefore, was mentioned like this: on the daily commute to work or on the way from work to home, you will pass several petrol stations and should observe the current price of gasoline. You know, because of the display of the fuel gauge, that you should refuel. One has to immediately decide about the refill at a particular petrol station. And there is one remark: a return to an already passed previously possible cheaper gas station is not considered. And we have given this task to students in school because we have collected those prices. We have created an interface to a certain institution where we got a lot of data. So we had an Excel file with about 50 megabytes of data, tremendous data we had, and the students were working on that. And the students had to create models. And we thought about a model created by the data. Very interesting. So you can see what the interface was creating for us. And then we realized, well, they will not be able to get any result because this is not that easy. So my colleague Thomas Götz and I have thought about another model, an abstraction of the model. And if you abstract the model, you can see it here. We can take into account the petrol stations and the prices of the petrol stations as a stochastic variable. And the goal is a strategy for finding the cheapest petrol station. That means maximizing the probabilities. So we have a max-min problem here. And we have given those ideas to the students and left the students alone for a week. They worked a week on this problem. And after the week, they had a solution. They had a solution which was very interesting. I show you the solution. The solution looked for the Model 2 like this. You see here certain letters. B is the cheapest petrol station, M is the average petrol station, T is the most expensive petrol station. And the students said, well, the first petrol station is our reference petrol station. And if we take this into account and come to the most expensive one, we will not refuel the car, we will go further. And so on and so forth. And if it's cheaper, we will refuel our car. So they found a strategy which is described like this. If the second petrol station is cheaper than the first one, you should refuel at the second one. If the second petrol station is more expensive, you should go on to the next one. And then they worked with that. And they have done very, very good calculations and were able to create an idea. And my colleague Thomas Götz and I have just abstracted this approach from the students to tell it to teachers. So we said, well, we take 1, 2, 3 for the petrol stations, and we can permute the order of the petrol stations, and we have a look at the permutation of orders. We can see that there are 3 possibilities to choose the cheapest petrol station, because we have taken no hierarchy among the petrol stations into account. So the probability for success is 1/3. That's the very first idea. The second idea is thinking about the strategy, taking the strategy of the students into account. The first petrol station is taken as a reference, you never refuel there. The second one, if the second one is cheaper, you will refuel there. If the second one is more expensive, you go on to the next one. And if you do so, you can see that you get the chance of 3 out of these 6 petrol stations to refuel the car at the cheapest. So the probability for success is 3/6 or 50%. And if you do these ideas further, and if you think about these idea further, you can observe the price of the first petrol station and just create a new model. Is the petrol station cheaper than the first one? You refuel with the probability P. Is the petrol station more expensive than the first one? You refuel with the probability Q. And if you abstract this one, then you can see that you can find a structure, and the probability for the best choice can be quantified by 1/6 times 2 plus P minus Q. And now our idea was maximizing the success. And when we maximizing the success and take our initial strategy into account, we can see that with the probability of P equal 1 and Q equal 0, our success is maximized. So we are at the 50%, and our probability for success is lower or equal 50%. So this was the mathematical part behind, and now we can simulate it. We just take this model and implement it into a calculation software. And we implement it in a calculation software. We can see that we are simulating for 2, 5, 10, 15, 100 or more petrol stations. And what you can see is that the probability for success is heading to a number 0.37. That's 1/E. How can we generalize that? Well, we can do that if n is heading greater and greater. Then we can see that the probability for success will be 1/E. So the best strategy for our success is 1/E. We have found a very common mathematical problem, that's the 1/E problem, by a real-life approach. But we have to be aware that the strategy is only successful when the number of petrol stations is known. And the condition is here guaranteed because of the known way. So now one could ask which skills and competences in terms of critical thinking is developed here. Well, I've listed that here. I think there are several skills and competences. I found 5. You have to find, understand, and use informations and use it on your own. You have to understand scientific evidence and create it on your own. So the validation of results is very important. The understanding how science generates evidence and what limitations are involved is important as well. So the understanding how a model works, validating, discussing, and reflecting on results for reality can be shown here. You're able to handle statistics and other representations of data, and the meaning of the question and the discussion of results gets very important. So we have seen the big data can be implemented in school very easily. Even bionics can be implemented very easily. You just have to think about folding a paper. So origami is a very interesting bionic part if you take biology into account. But I don't want to focus on that. I just want to focus on my last example, on the robotics, respectively on the automation. If we think about automation in mathematical classrooms, we have to think about interesting ideas. And in Germany, it's very common to play football or to look football at television. And if you look football at television, you get very interesting camera perspectives. And this camera perspective is created by a so-called rope cam. And we were thinking about, can we take the rope cam into account for mathematics classrooms? And my PhD student, Stefan Günster, he is here, and the PhD student of my colleague in computer science, Nikolai Pöhner, has supported me with this idea. And what you see here in this picture is a so-called rope cam, the rope cam as a model, which we have built and which is working. This is at the university in my office, and every day I'm playing with it. So this model was inspired by a rope cam like this. What you can see here is a real rope cam, which is sold here in Germany by Robicam. You don't have to know that, but I just mentioned that because Robicam was that handsome to allow me to take the picture. And we created a model which I want to show you in a short film right here. And then we talk about the mathematics. What you can see here is the camera. The camera is here. That's the wooden quadra here. Here is the camera. And the camera is running over the field. Here you see the motor and the interface, which was built by us. And we had to do a little bit of programming and a little bit of constructing for the codes, which was very interesting because we were able to combine science, math, and technique. So, oops. Yeah, now we were able to combine science, mathematics, and technique because we were constructing and building the coils on our own by a 3D printer. You can see them here. And we had to think about the number of revolutions per motor. So we were able to state that the radius influencing the coil is important, and that's what students also realized then very easily. So you know that, yeah? That was the first part. The more interesting part was the coding part. So the coding part was be done by Scratch in the first step. And you can see Scratch here, which can be transferred to the interface and where the Robicam is working. If you want to go further, you can tell your students, well, we don't take Scratch, we take Python into account. And if we take Python into account, we can work more easily. And you see both codes here, which we used for our model for the Robicam. And the mathematics behind is easy. The mathematics behind is just the theorem of Pythagoras, because you just need 2 points, and then you can use the Pythagorean theorem, or you can work with vectors. So in both ways, you can calculate the length of the rope, and then you're able to work with the model as it is shown here. Yeah, and the idea was heading from one point to another. And you can see how the camera is moving. And you can be aware that the camera is not moving straight. It's moving strange. So we were thinking about a failure which we had in our model. But there was no failure. This is just a problem of constructing. And this can be calculated, which is seen here. So the time dependency of the rope length is a big problem. We have tried to quantify that. You can see it here. And then you can just re-argue it for the rope length as a function of t and can use it for rasterization of the way. So this is a very hard mathematical world. If you rasterize the trajectory, you are able to optimize the way as it is seen here and as it is seen in the next video, where you will see 3 lines. The red one, the ideal one, the violet one, the optimized, and the green one, which was our first way and our first approach. So you can see, if we discretize our way, we are able to optimize the model. And we can think about this in a mathematical way, because we can have, we could have the idea of interpreting graphs. We are able to create the graph out of the simulation, and we are able to compare it to our video. So this could be done in mathematics classrooms as well. What I was not able to tell you because of time constraints, how the model is working itself, but we are able to recognize that skills and competencies are developed through this example as well. We have to understand, find, and use information and arguments, as well producing them ourselves. We have to recognize sources of evidence of trustworthiness and quality, and we have to consider alternative reasons, considerations, and critical questions without being confused. So one could say, well, those examples are very nice, but we are not able to do that in schools. That's not right. We have done all those examples in the meantime in schools, and some commentaries, qualitative, from students can be found here. It was really fun. It was exactly the things that I miss at my school STEM subjects. Connecting hardware, software was important to raise the mathematical problem in reality. Alone, no one could have done it. Very nice that it worked as a team, because we have allowed the students to work as a team. And it was interesting, new aspects, but like mathematical deepened. So they were critical as well, because they wanted to have more mathematics. Well, you see, there are a lot of possibilities how one could work with those examples in terms of STEM and in terms of critical thinking. What are we doing? I just want to give a short outlook and to make and to show you what is possible. I have a very big project funded by the Telecom organization, which is called LEAD, Learning Laboratories Inactive Experimental Digital. And what we are doing here, we are 4 colleagues from physics, from mathematics, from computer science, and from chemistry, where we are thinking about augmented learning material, about digital learning material, about learning, mobile learning, about the design of learning spaces, and about networking, school and out of school learning. And with this approach, we are sure and we can show that individualized learning can be done. Even in the context of STEM, as Obama has mentioned it, because Obama has said STEM is more than a school subject or the periodic table or the properties of waves. It's an approach to the world, a critical way to understand and explore and engage with the world, and then have the capacity to change that world and to share this accumulated knowledge. We have had that in the beginning of my talk, but Obama has told more. Obama has said it's a mindset that says we that can use reason and logic and honest inquiry to reach new conclusions and solve big problems. So I want to close my talk with this quotation of Obama, because I think mathematics and the M in STEM is a mindset as well. And I'm very happy to do the talk with you. Thank you very much for your patience and for your interest and attention. And now we have time for questions. And if you don't have any questions right now, you can write me an email every time you want and just re-ask what I wanted to tell you. So thank you very much. And I'm eager to hear questions now.
Yeah. Okay. Thank you very much, Stefan, Professor Schiller, for your wonderful presentations and this very nice and this comprehensive explanation about the STEM, the M in STEM, and also you start from the background and also the theoretically and also the example. It's very nice example about football, because as we know that Germany is popular with footballs, and this but I don't know, this Wurzburg football club. This also, yeah, football,
Yeah,
Wolfsburg.
yeah.
Yeah, it's near Bayern Munchen, I think. Yeah, so and yeah, okay. Thank you, Professor Schiller. And okay, there is some of the question, and also some of the participants would like to ask the question directly by but there is also the questions, and we as a committee would like to share the, yeah, because some of the participants, I think, just need to get the explanations in the resume in Bahasa Indonesia, and you can also read the questions in the bottom, that this is from the Miss Pastita Laksmiwati from Southeast Asia Kitab in Mathematics, and then you can read the question, and I will explain to the participant in Bahasa Indonesia about the resume. Ya, Bapak Ibu yang saya hormati dan para peserta, ini resume singkat ya. Jadi salah satu pendekatan yang dapat digunakan dalam mengajarkan STEM adalah dengan mengintegrasikan 3 subjek dalam pembelajaran. Kita dapat memandang matematika dalam STEM sebagai bahasa yang digunakan dalam sains, teknologi, dan teknik. Matematika sendiri merupakan subjek yang sangat penting yang dapat mendukung kemampuan berpikir kritis, gitu ya. Tadi disampaikan oleh Profesor Schiller. Prinsip-prinsip mathematical modeling, ya, ini tradisi dari Jerman dalam mathematical modeling menjadi sangat penting untuk membuat abstraksi dari suatu masalah sehari-hari, kemudian dipecahkan dengan menggunakan sains, teknologi, dan teknik, dan salah satunya dalam bentuk simulasi. Ya, dan ada kesempatan besar bagi para pendidik matematika menggunakan extended reality. Ya, dan baik itu menggunakan AR maupun VR, dan untuk menjembatani proses abstraksi dan modeling dan dari dunia nyata, ya, dan bahkan dari satu isu yang terlihat besar seperti big data dan dengan bionik pun bisa diintegrasikan dalam pembelajaran matematika di sekolah. Ini sangat menarik dan bisa kita kaji lebih lanjut, gitu ya. Dan ya, saya kira itu resume singkatnya. Dan untuk berikutnya, okay, and then the next, so we have the time for the question and answer. Stefan, we have the 2 questions written in here, and from the Miss Pastita, that I have questions regarding the approach of STEM integrations. It has been explained that the integration of STEM by a teacher is most difficult approach if a mathematics teacher want to implement STEM in his or her classroom. Yeah, and due to the lack of the resource, she or he has to implement STEM alone in his or her classroom. Yeah, but she should be prepared in the implementation of STEM to make the sure of the lesson taking place effectively. Yeah, this is a very good question. Please.
Yeah. Thank you for the question, Bastita. This is a very difficult one because it depends on the education system. In Germany, we have teachers who are teaching at least 2 subjects. So regularly, a mathematics teacher is teaching mathematics, of course, and then he is also allowed to teach physics, chemistry, or computer science. So it's easy to do this in his own education and in his own classroom because he is known to at least one of the other 3 subjects. But if you have if you don't have the chance to have this opportunity taking up another subject, I just would suggest be aware that mathematics is working interdisciplinarily. So that means if you take into account a problem like the rope cam, you have to be aware that you need computer science, you need physics, and there are a lot of ideas published in the meantime by my team where you can just read about that and where you can take this into account. And if you want to have more information about this, just ask me afterwards. I am allowed to send you certain things so we can go into this deep discussion. If you don't have the chance to be aware and to work interdisciplinarily, I think it's difficult. Then I don't see any chance to introduce STEM in this in this thing I have mentioned to you.
Okay, yeah, thank you very much for the answer for the questions, Professor Schiller, and yeah, I think this is clear for Ms. Pasita to answer this question. And yeah, okay, thank you, Stefan. And now for the next, I think Mr. Zuhair would like to ask, please, Pak Zuhair, would you like to ask some question, please?
Thank you, Pak Abdi. Hi, Professor Schiller. Hello.
Yeah, hello. Yeah.
My question is, in Indonesia, we only have a teacher with only one subject, like for prospective teacher who study in mathematics education, they are prepared for be a mathematics teacher, not to be the STEM educators, not to be a STEM teachers. And it is also for the physics and for the technology or in other areas. We only like one subject for one teacher. So I think STEM is difficult for for the way the Germany teach STEM is. I think it's quite difficult to be applied in Indonesia. Do you have any suggestion for us if we want to prepare? Because we are working in the department that prepare for prospective teacher for mathematics. So do you have any suggestion for us how we can prepare our prospective students to be a teacher with the ability, the adequate ability to teach STEM education?
Yeah, well, I think there are a lot of publications in the meantime from the professional side which you could use. So there is the ICTMA group. That's the International Conference on Teaching Mathematical Modeling and Applications, where you can find a lot of STEM problems which are usable in your courses. And there are other interesting resources one could use. So I would say there are a lot of materials available which one could use.
Okay.
If you want to have more information about that, I will give you that afterwards, but I have to look for that. That's no problem at all.
Okay.
Yeah.
Okay. Thanks, Professor.
Okay, thank you, Professor Schiller. That's Mr. Zuhair on January 2021 will start his PhD in Sweden in Umeå University. So he will start on January 2021. So they will come to Europe next year. So, yeah. Okay, thank you for the. Hello. Yeah.
Hello. Hello. I lost some connection.
Okay. Hello, can you hear me?
Yes.
Yes, okay, yeah, okay. And then for the next questions, Professor Schiller, this is from Abdul Aziz Ahwan from this my students. Yeah, this accepting presentations. And yeah, the question is, what if I'm a complete beginner and want to start learning and developing IoT about the STEM, and there are any recommendations for tools to start learning and developing IoT about the STEM? Yeah, this we can.
IoT is Internet or technology?
Yes, Internet of Technology, Internet of Things.
Yeah, Internet of Things. Yeah. I don't know any resources for the IoT. I have to ask my colleague, Martin Hennecke, who is the computer science researcher. And I think he knows a lot about that, but I'm not very used to this.
Okay.
Sorry, I have to ask, and I will give you an answer afterwards.
Okay, yeah, it's okay. And yeah, we have times, and in the future we can also discuss about it. And okay, thank you for the answer for this about the IoT. And for the next, yeah, this is from Imam Rahmadi. It's from Johannes Kepler University, Linz, Austria. This is a PhD doctoral. And yeah, he also joined. So thank you, Pak Imam. Yeah, this is the question is, please explain further about in your project and working on user-generated micro games and his Linz supervised by others. And yeah, okay, can you give some of the comment or give the feedback yet?
I would love to, because I know Marcus very well. He's done his PhD at the same professor as I have done. So just write me afterwards. We can think about opportunities about collaboration, of course.
Yeah.
Yeah.
Okay.
Can I say something, Pak Adi?
Okay, yeah, please, Imam, you can also ask directly.
Yeah. Thank you very much for your very interesting talk. Yes, I believe Marcus is close to your hometown, because I think he is also from Salzburg, and I'm
That's
here
right,
working with Professor Lafixa about user-generated micro game for supporting learning. But I was wondering about your last 3 slides about your projects. You mentioned the micro training and micro learning.
Teaching.
Could you please explain further about it? Because I see the connection between my project and your projects, since the games that I use is also very small games, what I call it micro games.
Well, the micro teaching is, we call micro teaching the laboratory teaching. So if you do this with a small group, we are doing micro teaching. If we are looking into math classrooms, we are talking about the macro teaching. That's the main point with that. And connecting to micro gaming, well, I think there are possibilities, because the game-based theory in mathematics is becoming more important. And if you do this with small groups, one could learn a lot. And then we just have to think about a scalable implementation in classrooms. So I don't have ideas about this right now, but I think this could be a very interesting approach to further research.
Okay, thank you very much. Looking forward to collaborating with you in the future.
Yeah.
Okay, yeah. Thank you, Sifat, and also thank you, Pak Imam, for coming. And yeah, we are waiting for our collaborations between us and yes, for the future projects, I think. And yeah, okay. And then there is still some of the question. This is from okay. This is from Ibu Ariworo. This is from UNNES. This is a lecturer of the mathematics education. And yeah, thanks for the present. And no, this is online because COVID-19 and industrial students studying mathematics still need direct guidance from the teachers. Yeah. And then this that the teacher cannot notice the students' mathematical thinking and respond the students' thinking, provided based feedback or scaffolding. Yeah, I think this is because of the in online. So yeah, cannot notice the students' mathematical thinking. What do you think? And yeah, please you can.
Yeah, I'm not an expert in noticing, but we have the same problem here. We are not facing our students face to face. We have online lectures. And what I'm doing, that's just from my point of view, I'm working with my notebook, with my iPad, and with a tablet. So I'm trying to get a very intensive contact with my students. And for this reason, this works very good. And I think I know they're thinking better than in the situation which was before, because we are discussing and discussing, but that's very time consuming. So I don't have a good answer for this. Although I think one is able to work individually and directly, because we have found ways with that. And we are doing this via Zoom. So in my opinion, it works. Although I agree with you, it would be very, very nice to face them face to face, of course.
Okay. Yeah. Thank you. Hopefully this yes clear for who Ariwara. Yeah, is also a PhD students in Unisa ya Bu ya, in Unisa in okay. And then for the next we have one question more that thank you for the comprehensive presentation, and that the practical issues are on the middle to high school level. I would like to know how to introduce the future-oriented issue in the primary schools. Yeah, this is related to the primary schools. Yeah, this again.
Yeah, that's right. I just talked about the middle and the high school level, even the university level, but not the primary level. There are approaches about the automation in schools. So we take Lego Mindstorms for practical issues in primary school, and there this works very good. So by using such tools, one is able to implement those topics in primary school as well. My staff member, Angela Betzold, is doing a lot of work with that. So if you're interested, I just bring you in contact with her.
Okay. Yeah, I think it is for a primary school. It is also important for and yeah. Okay, and then this we have times, and for the next, please, if anyone will ask some of the questions, or Faisal, would like to ask some question, please. No, yeah, okay. I think it is good, and I check the question from the. There's, I think this also already done, and ya, oke. Buat Bapak Ibu, kalau mungkin ada yang ingin bertanya, silakan bisa langsung bisa bertanya, bisa ditanyakan pada Profesor Schiller. Silakan, mumpung masih ada waktu. We have still 10 minutes before 17:30. But yeah, I think this is all of the questions already answered, and yeah, thanks. Very
that's good.
Nice presentations, also very nice discussions, and of course there is still have some of the problem or some of the questions that we need to discuss in the future, or we can make the collaborations between Würzburg and also in Semarang, and yeah, there is a lot of the projects. And okay, and this also still have the question from Ms. Virani that yes, I am interested about the future analysis, and yeah, we'll learn together about the STEM with PS. PS means
primary school teachers.
School teacher as well. Okay, yeah, and
all right.
Yeah, but in Würzburg, this is also the preparing the teacher for the secondary schools, for primary school also, or in Würzburg.
Yeah, we have all school levels, so primary school, middle school, high school.
Okay, yes, okay. And this is also, I remember that when I visit in Würzburg, that have a tour in the mathematics laboratory. This very nice laboratory with the mathematical modelings. Yeah, I think this traditions in Germany that you have the mathematical modelings. Yeah, and also yeah. Some of the group, very active group about the mathematical modeling. Yeah. Okay.
That's
we
right.
have also the new course in UNNES about the mathematical modeling. Start from this curriculum in 2020. We have the course about the mathematical modeling also. Yeah.
Very good.
Okay. Yeah. Okay. I think this enough for our discussions today, and thank you very much for the attention for the participants, and also thank you for the presentation from the Professor Schiller. That this is also nothing that some of the Indonesians say that is Professor Hans or Professor Stefan. Yeah, because in Indonesia normally we call with first first name. So it's
Okay.
Professor Hans and
Very
also
good.
Dr. Adi, so not Dr. Cahyono. So okay, so this is a culture, and hopefully in the future you will come to Semarang, and then we can connect collaborations and also. Before we close our discussions, perhaps you have some of the statement or others. You can please give some of the something like conclusion or others, please, Stefan.
I haven't. You were gone. So what was the last sentence?
Okay, please. You can give some of the last sentence for our.
Okay.
Today.
So thank you very much for inviting me for the talk. I'm honored to give the talk, and I am eager to keep up the collaboration. And I'm happy to meet you soon. Hopefully you all stay healthy, and hopefully COVID will disappear very, very fast. So stay healthy. Happy Christmas, Happy New Year. Stay healthy and see you soon.
Okay, thank you very much, Stefan. Yes, Happy New Year. And this is hard for, I think, in Germany, because this is Christmas in the lockdown. It's Weihnacht in lockdown. I don't know. There is a Weihnachtsmarkt in during the lockdown or not? No. Yeah.
No, nothing.
This is very nice when we can meet each other in Weihnachtsmarkt, I think. Yeah. Okay, but I think it's better and good choice to option to during the lockdown. Okay. Again, thank you very much for your time and also your presentations. And yes, hopefully we can meet each other in the next. And yeah, I guess stay healthy and also again, and thank you very much. And dan Bapak Ibu silakan presensi bisa diisi, gitu ya. Presensi bisa diisi di form yang sudah ada di di chatroom, gitu ya. Jadi seperti itu, dan sampai jumpa di lain kesempatan. Okay, thank you very much, Stefan. See you next times, and we keep in contact and discuss in online. And yeah, okay, and thank you very much for the participant for joining us. And now we have the 191 participant online in our discussion today. And actually we need some more time, but as you know that 17:30 we have to close, because after that we have the pray for Muslims. Yeah, this is also our cultures. And yeah, okay, again, and thank you very much. Good afternoon for the participant, and good morning for you, Stefan. Yeah, this is Stefan. Yeah, I think this is what time is it? Because this is
it's 11:30. 11:30.
Yeah. Okay. Yeah. Okay.
All right. Good.
Okay. Thank you.
Bye bye.
Bye and thank you. Ya, Bapak Ibu, terima kasih untuk perhatiannya dan selamat sore. Good afternoon and good morning, Stefan, and see you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih Pak Adi.
Sama Bapak Ibu. Thank you, Stefan.
Bye bye.
Thank you.
Bye.
Bye. Thank you.
Terima kasih Bapak Ibu semuanya, semoga bermanfaat dan
kesun.
Dan kesun. Bapak Ibu semuanya dan para mahasiswa yang ada di
Mas Adi.
Kami Bapak ada di Zoom maupun di YouTube. Ini YouTube juga banyak yang hadir juga ya. Terima kasih.
Ya. Makasih Mas Adi.
Oke, kami monggo Bapak Ibu kalau mau paling menyapa masih saya buka.
Terima kasih Pak Adi.
Oke, kami Bu Isti.
Assalamualaikum, pamit.
Waalaikumsalam.
Terima kasih Bapak. Terima kasih Pak Adi, pamit dulu.
Terima kasih. Mungkin bermanfaat. Silakan Bapak Ibu dan saudara-saudara, kalau untuk mengisi presensi sudah dibagikan oleh Pak Adi Satrio di chatroom. Dan terima kasih pada panitia ya. Jadi panitia ada
Thank you.
Pak Zuhair, Mas David, ada Aziz, ada Gozian, ada Faisal, ya, dan juga ada tim, dan sebenarnya biasanya ada Pak Amidi, tapi beliau sedang istirahat dulu dari kepanitiaan ini. Jadi untuk pertemuan sekarang, semoga dapat diberi kemudahan dan ya terima kasih. Dan juga ini dari teman-teman dari luar UNNES, ada teman-teman dari Seakim dan juga ada dari kampus-kampus lain. Terima kasih juga untuk kehadirannya. Dan saya tutup Bapak Ibu semuanya, nggih. Ini sudah jam 17.30 menjelang azan maghrib.
Bapak, matur sembah nuwun Bapak.
Sami-sami sama-sama Mas Bayu ya. Sehat selalu ya Mas Bayu ya, sudah sehat ini ya.
Iya Bapak, alhamdulillah.
Ya. Oke, dan ya baik, masih Sugeng Sonten, selamat sore, good afternoon everyone, and see you next time. Sampai jumpa di rebuan berikutnya, rebuan baik lecture series maupun rebuan, dan simak terus informasinya dari jurusan matematika dan dari web matematika. Jadi, terima kasih, sampai jumpa dan selamat sore, selamat beristirahat Bapak Ibu semuanya.
Ini ada yang tanya absen di mana?
Oh, absen. Ini sebelum saya tutup, ini di atas ini ada chat, itu ada Pak Asri Satrio, mungkin bisa dikirim ulang lagi, silakan. Nah, ini sudah dari, oh ini Mbak Ning ya, Jaratul Farida. Ini alumni kita dari Bandung ya, ini juga hadir ya.
Loh, bosnya hilang.
Masih di sini, Pak.
Oh, asik.
Pak, ini yang di YouTube juga diberi presensi apa mboten nggih, Pak?
Aduh. Pak Adi, gimana ini enaknya?
Ada yang tanya soalnya Pak di YouTube.
Sulit untuk mendeteksi kehadirannya.
Di-share aja, enggak apa-apa.
Di-share aja, Pak.
Menurut saya sih enggak apa-apa. Tanya hostnya.
Kalau saya sebagai co-host juga kayaknya nggak apa-apa sih. Hostnya gimana ini? Boleh nggak, Pak Adi?
Oh, saya belum aktifkan ini ya, tadi makanya ngomong terus kok nggak dengar. Ya nggak apa-apa, disampaikan saja untuk linknya di YouTube, kemudian bisa dikopikan di YouTube, nggak apa-apa. Karena memang pesertanya pendaftar lebih dari 300, jadi beberapa tidak bisa masuk. Ini ada yang masih
Nggak itu. Mau lihat closing, mau lihat terbukanya panitia.